Hello, algebra students. Mr. Lawrence here, and we're going to continue our exploration of these sequences and writing functions and graphing them. So, remember, the first thing we do, here's problem number one, we go and find the first differences. And it looks like we're going to add 3, then add 5, and then add 7, and then add 9, which means the second differences are plus 2 every time. Okay, automatically, right now, I know what kind of function this is. I know that it's quadratic. I have not stated the function, but I know it's going to be a quadratic function. All right, I know it's going to be something like n squared, right? When I put n in, I'm going to get n squared. So now I do my comparison line. Some of you are doing a little too much in your head. I mean, some of you can tell it's n squared right off the bat, but that's fine. But some of you are just kind of like skipping steps and you're getting things wrong. So let's square 1, let's square 2, and let's square 3, and square 4, and square 5. 25. Okay. Now I do my comparison. How do I turn 1 into negative 8? I think I subtract 9. How do I turn 4 into negative 5? I subtract 9. 9 into 0 by subtracting 9. Looks like my nth term will be n squared minus 9, which means my function, and this is important, a lot of you did this wrong in the video quiz last time, my function is f of x equals x squared minus 9. Okay, the nth term, the expression is n squared minus n, but the function is f of x equals x squared minus 9. So there's my function right there. Now, I'm going to graph that and see what it looks like. I'm actually going to do it on a graphing calculator here. Oops, I probably should have put myself in arrow mode. There we go. Okay, let me bring my graphing calculator up. And I don't know if you've realized this, f of x is kind of like y. It denotes a function notation, but it's very much like y. So I'm going to do x to the second power minus 9. And then I'm going to hit graph. And look at that. I get a nice parabolic shape. This is called a parabola, right? Oops, looks like there's another function left in there. Hold on, let me get rid of it because that's going to screw us up. It's probably down at number 8. Yeah, it sure is. Let me get rid of that. Okay. And now I can go back to the graph and it should look pretty. And it looks like it's going to redraw it. There we go. Okay, now my table said that when x was 3, y was 0. Well, look right here. I don't know. Hopefully you can see this. Let me blow that up a little bit. X is 3, so this is my x-axis right here, right? So here's the x-axis, and here's the y-axis. Or if we want to say in function notation, we can do the f of x-axis because we're putting x into the function. This is my origin. You should already know this. This should be review other than that f of x thing. Okay, and so when x is 1, 2, 3, it sure looks like y is 0. Right? 0, oh, sorry. 3, 0, not 0, 3. Okay. Now, if I hit trace, let me get back in pointer mode here. Trace, notice when x is 0, y is negative 9. That matches your table, doesn't it? And I think I can hit any x value, like 3, hit x, and then hit enter, and boom, look at that. It's sitting right on that pointed spot. Now, what did we get when x was 4? Gee, I don't remember. Let's punch in 4, and there we go. We get y is 7, and that should match the table. Okay. Now, by the data you have, your graph would have only been to the right. Let me see, do I have a highlighter in here? I don't know if I can get a highlighter from this position, but that's okay. You would have only graphed this part. It's really hard to draw a curve with these airliners. I apologize. Okay, you would have only gotten this part of the graph. Of course, it would go forever. Mathematically, the function would be the entire parabola. Based on the information I gave you, it would only do this. If it was in the context of a story problem, then you wouldn't include this. So you have to determine the context. All right, let me minimize that, and let's go on to the second problem here. All right, I've given you some more data, -3, -2, -1. So I am going into the negatives. Let's find the first differences. Looks like it's +5. Oh no, it's -5, isn't it? Oh yeah, -5. Well, that's weird. And then -3 and -1. But then it starts to go back up again. +1, +3, +5. This looks kind of strange because I don't remember seeing it go down and then back up. Well, I guess technically it's going up, isn't it? Because I'm taking away less, I'm taking away less, I'm taking away less, and now I'm taking away a lot less. In fact, I'm adding, and then I'm adding more, and I'm adding more. But let's go and see what the second differences are. And maybe I'll focus over here more. Looks like what? +2, +2. Oh, it looks like a lot of +2s are showing up. I'll bet you this is going to be quadratic. Yeah, it's showing up +2 all the way. It's quadratic. Okay. Now, by the way, you don't have to get +2 every time. You could get +8 or +6 or something like that. It's if the second difference is the same, it's quadratic. And Mrs. Clark pointed out to me that she noticed that the coefficient for x squared is always half of this value. So this is a quadratic function. And remember how we're going to do something with n squared, right? Well, the coefficient here is 1. It's half of that. If this were a 10, then it would be a 5n squared. So let's do our comparison line. I should change some colors here. And let's see here. Let's just start from the 0. I'm more comfortable with that. 0, 1, 4, and then 9. And I have to turn these numbers into the blue numbers. It's like -3. It's like -3. Looks like -3 all the way down. Now, what would happen with this one? Well, it would be 1 squared, right? -1 squared, which is 1. And then I would subtract 3. So it still holds the pattern. Even though I didn't feel comfortable with it, I was still able to see the pattern. Now, so then n squared -3 will be my expression. My function will be f of x. Oh, I'm sorry, it's h of x this time. H of x. And that'll equal x squared -3. X squared take away 3. Let's see what that graph would look like. All right. So let's go here. And we don't want -9 this time. I'm just arrowing over so I can edit. We want -3. And I need to get rid of all this extra writing here. It's unnecessary. And let me graph. And there come my axes, and there it is. And of course, we do know that this function continues forever. The calculator doesn't show that. The calculator is a very handy tool, but it cannot think. It can only do what it's told. There's my origin, there's x, and this is f of x, or you may call it y. But since we're dealing with functions, I want to do f of x. All right, now again, if I wanted to test and see if I had some right, let's see, when x was -2, I should get 1. So I can go like this. I can go trace right there, and then put in -2 for x, and sure enough, I get 1 out for y. See it right there? Okay, that would be the point -2, 1. That's on this function. All right, one more, and then we're going to wrap it up. I really think you're going to like tomorrow's lesson, by the way. Let me get rid of this, and we'll minimize that. And I'd love for you to pause the video on this one and see what happens. Okay, here comes my solution. Let's see, I'm going to work down here. It looks like I got +1 and +5. And, oh, what is that, 19? Doesn't seem right there, but that's okay. 62 and 25. Well, if it was 65 and 25, I'd be at 40. But I'm 3 less, so I'm only at 37. Ah, there we go. That +5 is not right. I knew it wasn't right. +7. There we go. That looks better. Now, by the way, I could go here plus 1. Look at that. It's doing the same thing. So I don't have to keep looking the other way. I'll just kind of focus on these. So we've got what? Plus 6, plus 12, plus 18. Still don't have them repeating, but when I go down to the third level, it's going to be plus 6 and plus 6. Since I'm on the third differences, this is going to be some type of n cubed. N cubed. So let me just test a couple here. 0 cubed is 0. How do I turn 0 into negative 2? Well, I take away 2. 1 cubed is 1. How do I turn 1 into negative 1? Well, I take away 2. 2 cubed is 8. How do I turn it into 6? I take away 2. This is going to be n cubed minus 2. This is a cubic function. Oops. Cubic. And then f of x is going to equal x cubed minus 2. Right? If I test it, x cubed, 4 cubed is 64. 64 minus 2 is 62. How about negative 3? Well, I'm going to do f of negative 3. And that's going to be negative 3 cubed minus 2, right? This will be a negative 27 minus 2 equals negative 29. There you go. All right, so let's go ahead and plot this function and see what it looks like. So y equals, I need x cubed and minus 2, I believe we said, right? So let's get a graph, and it's drawing. There it goes. Look at that. I don't know if you realize this, but this is very much like the quadratic, except it doesn't bend down. The quadratic would have done this at this lowest point and would have gone back up in a mirror. Well, it's not a very good mirror, but you see it's bent down this way. Ask me to show you a thing with my thumbs. I can show you how I visualize it. Okay, so there's the cubic. All right, so let's check out some of the values. By the way, I don't know if you can tell, but this table over here, I can bring it up, make it larger. Oops, is it not taking it? Second table, no. There we go. There's my table. Let me get rid of the f of x and stuff. If you look, when x was negative 3, y was negative 29. X was negative 2, y was negative 20 or negative 10. And x was 4, y was 62, and then it actually keeps going. Like, I could get more numbers, I think. This is not letting me. I'm doing something wrong, but anyway, so can't seem to get out of this. All right. There we go. Maybe there's just a little computer lag going on. There we go. Yeah, see, I can figure out pretty easily what x to the negative 9th is, or negative 10th, negative 11th, etc. Okay, and I press it so many times, it's still going. All right, so that's it for the video. We know, let's recap real quick here, as soon as this computer stops. Oh, Jiminy Christmas, how many times did I press this thing? All right, sorry about that. Okay, so let's recap real quick. We know that when the first difference matches every time, first difference is constant, it's constant, the function is linear, right? When the second difference is constant, it's quadratic. And we know that when the third difference is constant, we know that it's cubic. Right? Okay. Sorry, forced difference. All right, that's it for the video. Mr. Laurence signing off. Have a good night, everybody.